really neat. Okay. Um, so welcome. And I don't think I introduced myself. So I'm Sean Murphy. I have been there since the beginning, so to speak. And what that means is that um, actually I started a process of kind of architecting a solution to face the HIPAA laws that were coming into place. And the problem we were trying to solve is that lots of electronic medical record data was coming online during the 90s. And it was obviously going to be very, very useful for research. At the same time, we had to confront patient privacy laws, and that if you want to use data for research, you're going to need to get both the patient to get a HIPAA notification saying that it was going to be used for research. And if you want to see identified data, the IRB has to specifically approve seeing data for only a very specific project. Much of what we wanted to do in research at the hospitals was allow people to find cohorts of patients for clinical trials and clinical studies. And that means they needed to know, how many people do we have who have diabetes, are on metformin, have a hemoglobin A1C greater than 6.5, because that's what my clinical trial needs, right? And I want to know how many patients there are just to know whether I can do my trial or not. I need 500 patients, par their 500 patients. So that became kind of the goal, but we had to do it in a way you couldn't just give people data and just say, okay, look through all this data and see, who is it that qualifies, right? Number one, that's an impossible task anyway, right? We have millions of patients. Number two, that would super violate patient privacy. So i2b2 was invented to allow you to do queries and find counts, but only then, and you could do all that with a relatively low bar, right? I mean, the hospital had to approve all this architecture, and the IRB had to sign off on all of the i2b2 architecture. But each individual using i2b2 did not need to get IRB approval. Now, if you want to get the data for a project after you found the cohort, yes, then you need IRB approval. So that was where we were coming from in creating i2b2, was how do you get a look of patients for research without violating any patient privacy laws, and making sure that hospital policy was enforced and so forth. So that's when we really started thinking about it. And in 2004, we got a grant from the National Centers for Biocomputing to help us kind of approach this problem with an architecture which wasn't totally clear at the time, I have to say. When we wrote the grant, it was a little bit vague in terms of like how we were going to approach it. The reason that we architected it the way we did is we had put something called the Research Patient Data Registry together at Partners Healthcare, as it was known at the time, not Master Memoriam, it's known as Partners Healthcare. And it was kind of gave us a look at how we could do this. It was only very specifically done for Partners Healthcare hospitals. The idea of i2b2 was that it's going to be able to be open source software that could be run at any hospital. That was the goal. So Mike Mendez and a few others at the time wrote a lot of code and put together the first i2b2 platform. And the i2b2 platform was released in 2007. It was the first open source clinical data warehousing platform as a whole platform. It's not just a database. since i2b2 is trying to really solve that problem, right, of giving researchers a look at patients without violating privacy and so forth, you couldn't just give them a database, right? So we invented the platform so you could use a client to look at. And it was on this World Wide Web thing, which was relatively new. Goal, of course, is to make electronic medical record data available, usable for research. And I have to say, when we first were putting it together, it had a real kind of love-hate relationship in NIH and in IRBs across the country and so forth, because it wasn't clear if it was really going to be successful in managing that fine line, right, between allowing people to see data for research on patients, but also protecting their privacy. So really, it survived the test of time in that, eventually we got pretty universal approval, but that wasn't clear from the beginning. So it was really a very novel kind of idea at the time. So here's what it has evolved into. It can now organize and transform all kinds of person-oriented clinical data. It doesn't have to be electronic medical record data. It can be clinical trial data. It can be genomic data. It can be data which is from the patient, like in REDCap, and then we can host it as well. And often we'll put all those into one i2b2. So for example, in the biobank portal at Mass General Brigham, we have genomic data. We have patient survey data that's from REDCap. And we have the electronic medical record data, as well as computed phenotypes, special machine learning data that then becomes available in a relatively simple format, which you're going to see, and Jeff's going to talk a lot about, and Mike's going to show you lots of demos. Relatively straightforward, right? Even though it's really complicated to put it together, the idea is it's straightforward to use, right? So people don't have to go through all the training and so forth, but you can really jump in and use it. It does let all the data become integrated into one platform. And indeed, on i2b2, it's all in one table, the facts table. So there's a huge table in i2b2 that's central, but it's very simply laid out. And we'll have a lot of discussion on that from Jeff, but which often has billions of rows. But the key is it's architected in such a way that it follows principles that allow us to search it in milliseconds, even when it's billions of rows long. And that was a really key point, right? Because the intention here is for people to be sitting there at their workstation waiting for an answer. So it couldn't be an answer that comes back, the next day, right? It really adopted this idea of ontologies, which is how do you name things and associate those names with codes and so forth that's inside the electronic medical record, and creating this flexible data model to hold lots of different kinds of things that patients have. It's a platform, it's a software platform, and it takes constant maintenance and so forth. And we always have to worry about security. I mean, it's really, it's quite a task, I should say, just to keep that software compliant. There's over 300 installations now worldwide. It includes many big networks like ENACT and NIH Recover. It's got the graphical query tool, which we'll all be experimenting with. It can now export custom analytic tables. And the assumption is that the data exports are always with IRB approval. So we have a very profound, I will say, layer of authorization and kind of steps where, first somebody can create what they want in the data set, but then managers have to approve the data set. Then there have to be an IRB associated with that when it's getting PHI, or DUA when it's getting limited data sets. And all the software, not the data, is available open source. The data that you're going to be seeing today is created out of thin air. It's demo data. So this, so demo data is open source. Just it's just our creation. Um, and there you go. Jack.
Talk about the data model. I got a degree in computer science before I got into all this, and I saw this data model and I thought this is beautiful. So that's what got me excited about i2b2. Talk about it. Um, so it's something. Let me pull some more bullets here. So Ralph Kimball in 1996 introduced this thing called dimensional modeling. So before that, data tables used to be what you think of as Excel data tables with one column per each kind of thing, like column for diabetes, column for metformin. Uh, Ralph Kimball introduced this dimensional modeling where you have what's called a star schema. And the star schema is one central table that has most of your information, all of your facts. So instead of having one row per patient and a column for many things, you have one row per fact. And each row is a patient, an encounter, and a fact. And that allows you to create these very flexible models where you can mix and match data in ways that you can't do with other tables. And then the star part of the schema are all the little dimensions that come off of it. So there's a patient dimension, a visit dimension, a provider dimension. These provide extra quick access data about those subsets of information. This type of approach became popular for enterprise data warehouses, um, and i2b2 was the first platform to think about using that um, for its data model. Um, OMOP has a observation table where you can do things kind of like this, but they prefer the format of having many specific data tables, which has advantages too. But um, I'm talking about it. So the really nice thing about having everything in one central table is that it scales really well with the relational database because of like all of the hashing algorithms in the database. You can search in order log n time. So if you have 100 million rows in your fact table, it only takes twice as long to search through it as having 1,000 rows in your fact table. So it's very, very fast. And here's the actual star schema. So the central fact table and then the dimension tables. And you can see there are some common um, primary keys and foreign keys, we call them. So the observation fact table has the encounter num, the patient num, the concept code, and it has like the modifier code and the provider code. And the patient dimension then has the link back is the patient num. The visit dimension, the link back is the encounter num and the patient num. The provider dimension, the link back to the fact table is the provider path. So using that, you can look across all of these tables and develop very complex queries that run very quickly. This is an example of the data table, the fact table. So you can see the concept code is like a particular ICD code or a LOINC code, which is a laboratory value, or a vital sign. And then there are various columns for putting values associated with those. So, and like a diagnosis code doesn't likely have a value associated with that. You either have diabetes or you don't. But a lab like hemoglobin A1C, you'd want to know what the actual value of that test is. So that goes in the appropriate column. There's a column for numbers, there's a column for um, text. There are various modifiers around that. There is, so you either have diabetes or you don't, but it could be, for example, a primary diagnosis or a secondary diagnosis, and maybe you want to model that. And i2b2 is very flexible. You could model it by having a text string in the text column that says primary, but there's also this more elegant way of doing it with what we call modifiers. So every uh, patient encounter code pair or tuple can have associated with it a modifier code, actually as many modifier codes as you want. And those modifiers allow you to provide extra additional metadata and subdata about the fact. So you can have primary and secondary diagnosis. You can model in medications, you can model like route, dose, frequency, things like that. And you can put all of that in the fact table. So it's a very elegant way of expanding the data model. This slide shows the ontology metadata and then the observation fact. So the fact is a little more straightforward to understand. You have a concept code, and then see for this patient and concept and encounter, but that's not on this slide. There's a modifier code, and in this case, it's primary diagnosis. The ontology metadata, I think I'm going to go over a couple of slides on what the ontology is and what that looks like before maybe we'll come back to that. There is a common data, i2b2 common data model documentation that we put together a few years ago that has very comprehensive documentation on all that. That is the link to the wiki that we are transitioning away from. It still works, but there will be a complementary page on the new wiki soon. So in i2b2, when you are querying data, you are querying it through ontologies. Ontologies in i2b2 speak are concept hierarchies. So you can see there are some that are just derived from the terminology itself. So ICD-10-CM, that's a diagnosis terminology. It's split up into different code sections based on the first letters of the code. And then as you open up subfolders, you drill down to specific sets of codes and then subcodes with dots, and that gives you a hierarchy. You can also create your own ontology to model whatever patient-oriented data you want. So there's this ACT research ontology that's shipped with the ACT ontology that allows you to query by Charlson comorbidities or Alex-Hazard comorbidities, which are predefined, call them phenotypes of various kinds of health issues. And there's also ways of querying whether a patient has a certain number of diagnoses or medications or procedures or labs. So you can go very deep with the ontology tool. It gives.
So in the previous first thing, when John was talking about the derived data, you can derive data and then you can have your ontology point to that derived data. So it's very close.
This no data, so really that's a framework.
Yeah, you can use them.
Mhm.
And is there a way to like search? Let's say you don't know where in the nest it is.
Absolutely.
Yes, okay.
That is a key function. Seldom do you drill through the whole ICD tree, but it is sometimes nice to search for a term and then look at where it is in the tree and
Exactly.
things surrounding it. Yeah, so there's a whole table set up for the ontology or the metadata, where you define a path, which looks kind of like if you're a command line person, a Windows or Linux file path. So there's folders, subfolders, and then you get to a leaf node at the end. So ICD-9 confirmed case, ICD-9 confirmed case. It's a COVID test. And then there's a descriptive name, which is what appears on the screen in the user interface, and then some various attributes to define whether it's a leaf or a folder or what we call a container, which is just a folder you can't drag in the UI. And then the code in the fact table that's associated with that. And that gets rendered in the UI something like you see on the left, where it's a confirmed COVID-19 case. And you can define your own ontologies or use ChatGPT to help you define them, which I've had a lot of success with. Metadata hierarchy. Yeah, this is just another look at how the hierarchy works. You can drill down into particular diseases. These are common i2b2 ontology categories. This covers most of what's either in ENACT or in the demo ontologies. So you have diagnosis, procedures, labs, demographics, encounters, providers, health history, exclusion, microbiology. Demographics in i2b2 are usually rather limited because usually one who has an i2b2 stores their data in i2b2 as what's called a limited data set, which means there are no explicit identifiers. The patient numbers are random numbers, but there are dates and the numbers are self-consistent. So you can figure out what patient 12345 was doing on January 1st, 1980, and it's not all blurred like a de-identified data set. I'm going to skip that. So as you drill down the ontology, it gets different levels, and there's a database column that tracks what level you're at. But I think I went deep on data model. Does anyone have any questions on data model before we turn it over to Mike to talk about the software platform? Yeah.
Just like to microbiology, how to define microbiology? Is it certain number of microbes detected in the patient samples or?
Yeah, I really, really glossed over that. ENACT does not have microbiology, and that's become what I work with most of the time. But the demo data provides a sample of microbiology. Our internal biobank portal has microbiology, so you can have like something as simple as does the patient have a sample or not, or if you have specific fact data about the samples, you can put that into. Yeah.
I asked my case of work hours, and I heard a woman arguing about text-based keys versus integer surrogate keys. I don't know if there's someone in the room who remembers that discussion you had and why you went with text-based keys.
Text-based keys. So like the patient num is an integer key.
The codes that link to the ontology are text-based rather than this.
Rather than
Yeah, because we wanted to keep the ICD-10. I know OMOS does numeric.
Right.
Because this came from the RPDI, we decided to use the actual code. The performance wasn't bad. It's also when you're looking at the database, you could say, oh, ICD-10, that's a LOINC, that's whatever. Instead of having a number and then having a select statement to figure out what that is. I think it was for both tools.
Great. Thanks.
It may be like milliseconds slower, but so is parsing the path, but it makes it much more readable and maintainable to have these structures.
So Jeff, I had a question. I think in Recover, there were wearable devices for the long COVID.
Mhm.
I just wonder, does that go under the health history, or do you create your own, piece of the model?
I think that's all going down.
Okay.
Yeah.
Okay.
Yeah.
That's what I was wondering.
Yeah, that was
where it goes. And it's kind of an evolving thing.
Yeah.
For some studies. I think Sean mentioned, maybe it was yesterday, patient data that's in RedCal. So
Yeah. Niche will be here this afternoon for the workshop.
Good.
Yeah.
So like instead of in OMOP where you have like 50 plus, maybe 100 plus tables, here you only have 6.
Yeah, it's more like 10, but yeah.
Okay.
It's many fewer tables. That's right.
Okay.
Yeah.
But the i2b2 platform can connect to an OMOP database. So, and Jeff did a lot of work on that. So, okay, so I'm going to talk a little bit about the platform and how how we kind of developed it. So we developed each of the major components, like the ontology cell that Jeff was talking a lot about, as one cell. And then we had another cell that dealt with the data, which would connect up to that star schema that Joe and Sean were talking about. And then we have a couple other cells, like the workplace cell. We have another cell called the project management cell. And this project management is the one that you log into. It will tell you what type of roles you have, like whether you see like obfuscated numbers, like plus or minus, or whether you actually see the real numbers, or whether you get all the data, even the ones in the blob, which has notes, encrypted notes and stuff. So the way that we developed it was whatever the business logic is, whatever like the magic that it does, it could be anything. It could be Java, it could be C Sharp, it could be Python, whatever. It just needed to talk to the other cells with a common XML format. And remember, this was back in 2007. So if we did it today, we do JSON, but this is 2007, and we're sticking with it because people have developed other cells, and it is just XML. It's just text. So it might not be as pretty as JSON, but so basically it's XML that goes back and forth that has like what the cell is, your authentication information, and various other components. And then there's a message body. And in that message body, it could be whatever the business logic is expecting. So the ontology has its own special one with children and parents, and I'll talk about the ontology. The CRC one has all the observation with all the observation fact information. But if there's any questions, just raise your hand. I don't know if I can see the Zoom people raising their hand unless something flashes on the screen. So yeah, so this is basically kind of like I just mentioned earlier. This is like the data model with the CRC cell, and then you can have your ontology cell, your workplace cell, and various other cells. And so this kind of gives you, so the ones in the dark blue are the primary cells. So in order to really be like an i2b2 platform, you really need those four. And then we had kind of the identity management, which was a way of converting that patient number that Jeff was talking about, that like fake number, into your real medical number or your EMPI number. And then the file repository was a way that originally we were thinking of ways of transferring like DICOM images or other larger files that really couldn't really fit in the CRC. That was the file repository. And then the other two, the i2b2 web client and the i2b2 workbench, were basically clients that would then connect up to these cells and communicate with them through XML to basically run queries, get data. The top one, the i2b2 web client, is what we currently have. The HMS team did a really good job of redeveloping a whole new one that looks really nice. The i2b2 workbench was what we called what was it, the fat client?
Yeah, it still exists.
Yeah, it still exists. It was
written in Java.
Yeah, it was written in Java. It was based off of the Eclipse code. And so we used that platform to develop a client. I think it was used also, it was kind of like one of our first ones, and then the web client came along, and then the web was just a lot easier to use. So, so I think I kind of went over this slide in detail, but basically, yeah, this is like the CRC. You have like the set finder, which is doing the queries, the patient data object, which is that 7 star schema is kind of in an object as XML. And then you have the CRC loader, which is a way to load data into i2b2, whether it's like through a web RedCap integration or little data coming in. I'm trying to think of, I know that I'm using it for something, I just can't back of my mind missing it. It's not intended to bulk load your data. So when you want to bulk load your i2b2 data, it's best to use something like SSMS or SSIS, which is the Microsoft bulk loader to load a terabyte of data into it. If you try to do it with the loader, You're gonna be like Sean was saying, like 30 years from now, you'll be done. The ontology cell, which Jeff was talking a lot about, that has like queries the ontology, the metadata, and returns that. The project management, like I said, that was for user authentication. You can either authenticate locally, like through i2b2, but most people do SAML or NTLM, which is the most common ones. And as Jeff talked about in yesterday at the 183, the new admin tool makes it a lot easier for the NTLM. It was really a pain. You had to like do 3 columns every time. It was that one. And then the workplace cell is kind of it's an underutilized cell. The beauty of the workplace is you can drag things into it. You can drag patients into it. So if you want to make a list of patients, you could throw the patients in it. If you were doing a clinical trial, you could grab all the patients in, then go through a chart review and be like, I don't want that one, I don't want that one. And then you could have a list of your patients, and then you could export that and then goes to your IRB. It's also a way I've seen people use it for like QAing when you install i2b2, set it up. It's a great way to put in queries that you want to run every time you do a reload and just drag it across, run it, and then, okay, it's working. So the workplace cell is a way of kind of anything that's draggable, you can put into a workplace cell. And I need to make sure I'm not going over time. So normally the 3 of us usually do this at AMIA, but we have like 4 hours, I think. So we kind of compress this down to an hour and a half and not make it too over the head. But anyway, this is just a quick example of what an XML would look like. It has like, and this is like multiple concepts, and you have concept path and then concept code and the name of it. So this would be what would be in the message body of an ontology. And only it understands what it means, but then it can pass it to someone else, and that cell then could learn about how it means and deal with it. And then this supported data models. Oh yeah, so Jeff made these slides, I'll admit. What do you want to say about this?
Apparently, and it is in 2017. Yeah, so i2b2 can connect to other data models through database magic. And the point here was that the XML interface is still the same. So you can use the same XML calls and the same user interface, even though we switched out.
Okay, great. Thanks.
Yeah,
Oh, and just in time for Jeff to do the query tool.
Talk through the query tool, and then Mike will demo it. I don't have my slide with the old 1.7 query tool in this deck, but this is the new query tool. So on the left, you can see there's the hierarchies that I'm talking about earlier. And on the right is where you build your query. The new query tool, you build it downward rather than across. So you put the things that you're interested in all being there in separate green panels. So here we've picked 18 to 34 years old, female, and ischemic heart disease. So one would hope that's a small number of people. And and then you can click find patients, which is cut off in that screenshot. And then this little run query options dialog pops up. By default, it says number of patients, and that'll give you a count of patients. If you are, it's called an obfuscated user, which many setups have their users obfuscated because it is even more privacy preserving than you get an approximate count. Or you might get an exact count if you have more administrative style access. And then there are a bunch of breakdowns. And the breakdowns here. So you can view a lot of different simple analyses as bar graphs. And I talked yesterday about how in the new version of i2b2, you can also view them as pie charts. tables, download CSVs. So there, i2b2 ships with these and a few others. You can see the breakdown of your cohort by gender, race, and age. There are more advanced breakdowns like top 20 diagnoses in this cohort. And then there's like the NIH enrollment table I was talking about yesterday, which does a very detailed breakdown of cohort demographics. We have local customizations of these tools, right? So this just shows the query tool modified slightly, but mostly with just different ontologies for different use cases. So in our biobank portal, we have genomic things. You can query by SNP with an RS identifier just by dragging over the SNP into the query panel, and it'll pop up a dialog that lets you type in an RSID. And there are curated disease populations, which are derived data phenotypes that are computed and put into the database. And then this is Dave was asking about the recover data. This is kind of what the sensor data ontology looks like. Another use case is Enact, which is our 50 or so sites around the US that are all networked together with the Shrine networking protocol. And with a common ontology, the Enact ontologies, which I've talked a lot about, and you can see with the old style yellow folders, you can see the Enact ontologies, the basic ones there on the right. And this is a query for women with diabetes. Not going to go a whole lot into Shrine, but it's a tool developed at Harvard Medical called the Shared Health Research Informatics Network, I think, that allows i2b2 to query each other and you can get patient counts across a large number of sites. So you can see how much of a cohort you would have if you say partnered with Mayo or Pittsburgh or something like that. And then you could, work with them in a data enclave or some other kind of arrangement to do data analytics. But, at a glance, automatically you get patient counts from all of these sites around the US just by running a query in the Enact Shrine tool. These are the types of things you can query. Kind of showed this in various ways already. So I'm not going to spend a lot of time on this slide. Mike will walk through some of these queries, but there are a lot of standard medical terminologies that are important to become a little bit familiar with if you're going to run a lot of i2b2 queries. This is the types of things you can create in the query tool. You can have things that are grouped together as ORs. So you can pull over a bunch of different beta blockers and have those all on a panel, and then a patient with any of those will appear. Or you can put them across panels, which I showed, so the patient in that cohort have all of those things. You can set a bunch of constraints. So you could say, I only want patients who have 3 or more occurrences of propranolol in the medical record, which you can maybe tell the difference between chronic use and individual use. Date constraints are also really useful. If you're only looking for patients for a study that has to be pre-COVID, then you would set a date constraint before 2020. And then the value constraints, if you again drag over something like that SNP leaf that I showed earlier, then you get pop-ups that let you pick values. And Mike can show you some of those. Some of them get pretty graphical. All right, live demo.
So we might want to swap out machines. See, we're using mine.
Yeah.
Let me talk to some people.
So, can we use your machine?
It'll be got too much weird stuff on it.
Oh, too much, okay.
All right, so for the Zoom folks, we're gonna take like 2 or 3 minutes
Yeah.
and put Mike's machine, because Mike's machine is the one that's all, set to do the demo, and we're using. So just hang on with us for a few seconds, and we will get this done. We will be back. Oh, I'm still connected. Okay. This is.
Um, yeah. Yeah. Okay. Okay, great. And then the other one is, the other major role is. Okay, I don't know why I went there, is the administration role. And that's kind of the administrator. They can create project, create users. You're basically an administrator. Okay, so now I'm going to jump to the actual web client. And so this is the new web client that was developed. One thing I want to point out is we have all these projects, and that's what you can do in i2b2. You can make projects. You can have project for asthma, project for diabetes. You can break down each of your IOBs to have their own project. Or you could have one main project, which what a lot of people do, which has all your data. So I'm going to do the i2b2 Act 9, which is the one we use. You can also have announcements that come up. So the announcements can basically be all activities being logged. Or it could be that next Saturday at 5 p.m. we're reloading the database and the system will be offline. So I know it. Hold on for this one technical history. Clear recent history. Okay, so what actually happened back there was I had upgraded the web client on this data enclave to the official RC1. And so the previous cache that I had was the old stuff. And so that's why it didn't come up properly. Normally you wouldn't see that. If you do install i2b2 and you upgrade, tell your users to clear the cache because they might have their old cache trying to use some of the new stuff. But anyway, so I'm going to go through each of these panels and then we can run queries. So as Jeff had mentioned, this is all the ontology. And then right here is actually where you can do a search. So if you have no idea where asthma is, you can do a search for asthma. But you do know that asthma is actually a diagnosis. Is a diagnosis. So then if you select that one, you do a search, and then it comes down, and then this number right here, this 3,000, is the number of patients in that category. And as Sean was mentioning earlier, we created something called the Cynthia data set, basically from MITRE. It was basically a data set that synthetically looks real, but it really isn't. So they have like, in Boston, they would have more patients that have this type of disease versus someone in Newton who has this type of disease. But it was all just made up. But it looked kind of realistic. So yeah, so if you do a search for asthma, it comes up and then shows you. So then you can actually drag this across and drop it in here. And so then you're doing a query for all patients who have asthma. And you can say with asthma or exclude and say without asthma. You can also set a date range, as Jeff was talking about, and that he wanted me to demo. Then you can say, okay, I want to have anyone from February 1st, 2020 to now. And it has to have at least one occurrence. And then you can click on Find Patients. And so then this is that pop-up that shows you all the various different breakdowns you want. So the major one is like number of patients, which is clicked by default. You can create a patient set of those patients, so you don't just get an aggregate count of the patients. You can actually get a patient set, and then you can utilize that patient set in other queries. You can do breakdowns, which was showing that graph that Jeff had demoed. You can have like the gender breakdown, and then you can have more sophisticated breakdowns like the NIH one or the zip code breakdowns, or you could actually create your own. That's in the next training class. And so if you run the patient, it runs. And fingers crossed we don't have any issues. And so we could see that we have 35 patients versus the original one which had 3,000 patients. And so we added a date constraint. So most of the patients were before 2020. And so once you run a query, it shows up in your previous queries. And you could do, let me clear this out. You could do fancy things like then use this patient set, this query in another query, which we call query in a query. And then here is that workplace cell that I was talking about earlier, where you can drag things in. So you can drag in a concept. Why is my mouse not dragging it in? Yeah. And then you can reuse that query, that concept, now that you saved it. Is this making sense, or do you have any questions? Yeah.
The right order of operand, if you try to do something that repeats.
So what it will do, it will get all those patients for the first query, and then it will narrow down against the next query. So it will narrow down those patients. So everything's based on patient numbers. Okay, I'll go a little bit over the data export that we developed in the 182. So I always grab the wrong one. Oh, sorry. Yeah, I wanted to write it. Okay, so now you can export data. You can export like we have predefined ones like medication diagnosis, where it has the table set up that would look like the RPDR that some of you have used, or you can make your own export pivoted table. So there's some default ones like gender, age, and race, but then you can drag over. Any of these have? I'm going to use asthma. You can drag over asthma, and so if you then you can set constraints on this, but then you need to save this table. So I'm going to save the table, and this is going to be June demo. Okay, so now we have a table that we set that has gender, age, race, and asthma. And so then you can use that table in a query. So we'll do a new query, and I'm going to do diagnosis, demographics, age. Let's see. I'll do 18 to 35. Okay, so I'm gonna look for all patients who are in this age. And then I want to use that data set to export those. So if we go in here and then we look for June 10th, user created June 10th demo. And you run this. So we have 23,000 patients who are between the age of 18 to 34. But we also create a data set for them. So this is where the manager would then have to approve it and then export the data. So we're going to pretend like the manager logs in. Act. And also the manager would get an email saying that someone ran a query and they're looking for the data. Export. And then we go to the data request manager. And then we see that we have this one query right here from 18 to 34. We can look at the details of it. And then it was submitted today. You can actually click on the query to look at it. And then, but the major thing is, so you can add comments to it. You can change the status. Right now it's pending. But if you want to run it, you click on create files. And so now it's creating the data set for them. And the data set can be exported. It gets exported onto a file server. Yep.
Automatic request.
Yeah.
And then what if we want to reject?
If they want to reject the request, you can, I'm going to reject this one, this heart rate one. You can change the status to denied. And so that request has now been denied. And if you go back here, it says denied and shoot, it says error. Okay.